Hello class, my name is Uche Martins. Welcome to Basic Science and Technology class. Today we'll be treating the topic Gears Part 2 with the theme Tools, Machines and Processes. Let's look at some objectives of this lesson. By the end of this lesson, you should be able to identify some gears with non-parallel and non-intersecting axes. Also identify sprockets, internal and external gears, and also list some general uses of gear. Also, by the end of this lesson, you should be able to determine gear ratio. You should be able to understand the relationship between gear ratio and speed of rotation ratio. You should be able to state the functions of lubricants in a gear. Let's take a brief introduction to what gear is all about. Gears are toothed wheels that rotate and engages with other toothed wheels or with a rack. We all know that a rack is a non-rotating part associated in a gear. In order to transmit power or change the speed or direction of the transmitted motion. Some gears with non-parallel and non-intersecting axes are screw gear and worm. We also have our worm wheel. This is a diagram showing a screw gear, and this is a diagram showing a worm and a worm wheel. Screw gear. Screw gear is a type of helical gear, also called your cross helical gear, used in motion transmission between non-intersecting shafts. You can see that these shafts are not intersecting with each other, but they are using transmission of power, torque, and load from one part to the other in the gear machine. It transmits power, load, at right angle like bevel gear. Screw gears have lower efficiency than parallel or perpendicular shaft gears. Why do we say they have lower efficiency? Because they don't transmit heavy loads. Worm and worm wheel. A worm gear is a gear composition made up of a screw, a one-tooth gear called a worm that interlocks with a gear called a worm wheel. We should know that the worm drives the worm wheel, and also the setup is used to transmit torque and to determine the rotational speed in a gear system. This is a worm and this is a worm wheel. The worm drives the worm wheel. Let's look at another type of gear called sprocket. These are types of gears with toothed wheels used to aid chains and belt drive in a pulley system. Sprockets are never interlocked together directly but use chains and belts between wheels. Sprockets are used in bicycles, motorcycles, etc., and in other machines to transmit rotary motion. Now, let's call this sprocket A and this B. You can see that the tooths are not interlocked with each other, but with the aid of this chain, it is used in transmitting power from one point to another. Internal gears are types of gears in which the teeth are caught on the inner surface of the cone or cylinder. You can see this is the cylinder and the teeth are caught inside on the inner surface. When we have the teeth made on the inner surface of a cone or cylinder, we'll say that is an internal gear. It transmits load better because the tooth are cut internally with less slippage. That means there is no much power loss because of the transmission of power internally. External gears. These types of gears have their teeth cut on the outer surface of the cylinder or cone. Unlike our internal gear that will have it cut on the inside, but for external gears, you can see that the teeth is cut on the outer surface of the cylinder or cone. This is a simple gear arrangement made up of two gears. One is the driven and the other one is the driver or the driving gear. Now, the driving gear is normally connected to the power source of the gear, and it transmits power from the power source to the driven gear. Now, the simplest gear train has two gears. The driving gear, which is also called your input gear, transmits power to the driven gear, which is also called your what? Output gear. The driving gear is usually connected to a power source, such as a motor or engine. Let's look at the relationship between the gear ratio and speed of rotation ratio. Gear ratio is simply expressed as the ratio of the number of teeth in driven gear wheel to the number of teeth in the driving wheel. We can also express it as the number of teeth in the output gear, since our driven gear wheel is also referred to as our output gear wheel, all over the input gear wheel. When you see an expression of the number of teeth of driven wheel over driving wheel, it is referring to the gear ratio. Now, let's look at the relationship of the gear ratio to speed of rotation ratio. Gear ratio is also expressed as the ratio of the speed of rotation of the driven wheel to the driving wheel. And this expression is also referred to as speed of rotation ratio. So the ratio of the speed of rotation of driven wheel to the speed of rotation of driving wheel is what we refer to as our speed of rotation ratio, which is also expressed as our gear ratio. Now let's take a look at this example. The number of teeth in the driver wheel or driving wheel is 25 teeth, and the number of teeth in our driven wheel is 75 teeth. If we were told to calculate the gear ratio, it is simply driven over driving. That is 75 over 25, which will be 3 all over 1, which is 3:1. So this becomes our gear ratio. Let's look at the general uses of gears. Gears are generally used for the following. 1. It is used for power, torque, and speed transmission. 2. It is used to change the direction of rotation. Gear can also be used to change the direction of speed of rotation. It helps to also control the amount of power transmitted. Gear friction. When there is sliding friction between gears, it can lead to loss of power as well as a potential cause of vibration and noise. Therefore, to avoid this loss of power and problems like wearing and tearing of the part of a gear, what we do, we apply lubricant. Therefore, to avoid problems like wearing of gear tooth and premature failure, lubricants such as gear oils and grease should be applied to the gear teeth so that it does not wear and tear and fail when used. Let's look at functions of lubricant on gears. Some important functions of lubricants such as grease and gear oils are: it helps to reduce wear and tear of gear wheels. It also reduces power loss from overheating of the gear wheel. It also reduces the resistance of rotating part of gears. Application of these lubricants reduces cost of maintenance. Let's look at the summary of what we've learned so far. We learned that screw, worm, and worm wheel are types of gears that are non-parallel and non-intersecting. Sprockets are types of gear with toothed wheels used to aid chains and belt drive in a pulley system. We also learned that gear ratio may be expressed as the ratio of number of teeth in driven gear wheel to number of teeth in the driving wheel. We also learned that gear ratio is also expressed as the ratio of the speed of rotation of the driven wheel to the driving wheel. We saw that lubricants such as gear oils and grease must necessarily be applied to gear teeth to prevent wearing of tooth, loss of power, etc. Let's take some questions. Question 1. If the number of teeth of the driving gear wheel is 40 and its gear ratio is 2:1, what is the number of teeth in the driven wheel? A, 80, B, 40, C, 20, D, 40. Let's look at the solution. We know that gear ratio is simply the number of teeth in the driven wheel over the number of teeth in the driving wheel. Now, from this question, they said the number of teeth of the driving gear wheel is 40 and the gear ratio is 2:1. Gear ratio 2:1 is equals to number of teeth in the driven wheel was not given. So, driven over, and the number of teeth of the driving gear wheel is 40. So we have 2:1, which is 2/1 is equals to number of teeth of driven wheel over 40. Let's cross multiply. So we have 40 times 2 is equals to number of teeth in driven wheel, which is equals to 80. So the number of teeth in driven wheel is A, 80. Question 2. Dash is a gear used for transmitting power when placed side by side to each other. A, spiral gear. B, herringbone gear. C, helical gear. D, cross helical. The correct option is B, Herringbone gear is a type of gear that transmits power when placed side by side to each other. We've come to the end of this class and be able to understand what gear ratios are all about and also the importance of lubricants in our gear machine. Thank you and see you in our next class.